Hi guys, in this video we are going to see the data science and machine learning pipeline. We are going to understand different steps involved in any data science project. So mainly there are 11 steps, and first and the most important is problem definition. Problem definition. So let me give you an example. If I say analyze the sales data of a retail store, analyze the sales data of a retail store. This is not a problem definition. But if I say analyze the sales data of a retail store and identify let's say products with lowest sales. Let's suppose we want to identify customers with highest purchases, highest purchase frequency, you may say. Let's also identify times with lowest and highest sales, maybe in a day, maybe in a week, maybe in a month. So identify these three things and then come up with a marketing strategy. Marketing strategy to increase the sales by 10%. Now this is a problem definition. Now there are three major things in a problem definition: clearly explained problem, the impact, and the desired outcome. Now the key point is there is an engineering procedure which we can follow step by step to understand and define a problem. So this engineering procedure is closely related to requirements engineering in software development, or requirements elicitation, which is a engineering procedure to come up with the right requirements, and then using those right requirement tools and techniques, we come up with a very well structured problem definition which contains a problem clearly explained, the list of impacts, and the desired outcome. We'll look into this in more detail in a separate video. This is the first and the most important step. Without this, you will never get a clear understanding of what you are doing. So again, analyze the sales data of a retail store is not a problem definition. It's not at all. The second step that we follow in data science or any machine learning pipeline is data collection. So data collection, there may be multiple sources. So there may be an entire data infrastructure. And this data infrastructure may involve databases, may involve data lakes, maybe a warehouse, data warehouse, and they may be deployed at different platforms, different cloud platforms, maybe AWS, GCP. On AWS, somebody may be using different services. For example, AWS S3, RDS, Redshift, arena, different kind of tools and services may also be there. So an entire data infrastructure may be there from where we may need to take some data sets related to the problem. There may be third-party APIs. So one is data infrastructure. There may be third-party APIs, from where we want to get this data into some JSON format. These may be from web scraping, or some other source, maybe some Excel sheets, or documents, maybe some PDF documents, or in worst case scenario, we may need to conduct an entire survey. And in this survey, we will have to follow the entire science of survey and data collection, and then there may be so many biases and so many things, so many nuances which may need to take care, so that the survey that we are doing and the questionnaire that we are generating actually generate the data which is relevant for the problem that we are trying to solve. So that may be an entire step. Then there may be data augmentation and different steps involved. So we may need to have an overall understanding of different sources, and our data may be located at different places in the entire organization, and we may need to come up with some kind of a pipeline or some kind of a solution to integrate with all these and then collect the data into a single repository, or we may have to build some kind of a data infrastructure or play with some cloud services already there. Third is data preparation. So this is a place where we kind of integrate and transform data which we can analyze in a way in form of a data frame. So we may use pipelines like pandas and numpy, and then we are doing a lot of data cleaning and data pre-processing. So steps like data cleaning and pre-processing is involved at this stage. You may have null values over there. Then this data at the end of the day is going to be analyzed by some computer algorithms, and these algorithms understand numbers, and data may be categorical or a string or different kind of things. So you may need to convert or like integrate everything from different data sources to some kind of a single structure in a way or in a particular format that can be analyzed. So that is our third step, the data preparation. Fourth is kind of EDA, exploratory data analysis, basically, and visualization, data exploration and visualization. Exploratory data analysis and visualization, whatever you want to call. So here we try to find out insights and patterns. Different insights and patterns. For example, what is the impact of null value on the target variable? If we drop a null value or we convert and consider it as a separate feature, there may be a lot of things that we need to work on. We try to draw a lot of visualizations and see different kind of charts, and it's a separate subject. There are mainly a few, around 7-8 important techniques or important steps that every data science pipeline should follow to perform at least basic exploratory data analysis. So in a separate video, we are going to cover what are these 8-9 basic steps which are necessary, and then project to project, case study to case study, there may be a lot of techniques involved in this step. The fifth is then feature engineering. So in step 4, we are using a lot of descriptive stats. Here we are using different tests. There are different kind of tests. For example, let's suppose chi-square test is one of them. So different kind of tests we apply to select some feature or to generate few features from existing features. So statistical tests are there, and our two main ideas are feature selection, selecting important features. So let's suppose we build some kind of a covariance metric to come up with the features which may be important for us, implement some tests, different aspects. We will look into this in a separate video. And then engineering, come up with a new feature with the existing features so that they can be helpful in predicting the target variable that we want to generate. So it itself is a big topic which has to be covered separately. Once we do the feature engineering, the next important step is model selection. So in a way, we are saying that we want to find out the probability of our target given the input data and the model parameter. So when the input data and the model parameter is given, what is my probability? And this we say is some probability distribution. Some probability distribution. And then we may select a particular probability distribution to model the problem. So somebody may come and say that the probability of my target given model in theta is kind of a Bernoulli distribution. So we are modeling our problem as a Bernoulli distribution, and there may be different kind of probability distributions that we can have, and then we may use a sigmoid, some function to map some numbers between minus infinity to plus infinity, between 0 and 1, and kind of represent like probability. And then in such a case we say that this is one kind of a machine learning algorithm called logistic regression. So basically model selection involves selecting one or many different machine learning algorithms or different probability distributions, and then work around and see which fits the best. There are some standard ways to actually come up with the right model. There are different models, parametric, non-parametric. The example that we have seen is kind of a probabilistic modeling, where we are using some special techniques like maximum likelihood estimation or something like this. Then there may be some other models like linear regressions, where we try to reduce the error function. There may be non-parametric, non-probabilistic models like decision trees, or unsupervised learning models. Maybe a clustering algorithm is there for anomaly detection, or like similarity search. Different kind of models for different problems. What is the right model for a particular problem? Once we find out the right model, then we go for model training. So once we have modeled the problem, with some probability distribution, with theta as a model parameter, some unknown numbers related to that. So we want to maximize the joint probability of our model parameter, maximize joint probability of theta model parameter over entire dataset. And the way we do it is we kind of like optimize the log likelihood function. So we either maximize it or we try to minimize the negative log likelihood. One way, there are different ways. And then to optimize it, we can use different optimization techniques like Newton method, or somebody may use Gauss-Jordan, or conventionally what we use, because then we in our discussion we'll understand kind of like non-convex high dimensional likelihood functions or non-convex high dimensional error surfaces, and then techniques like different variants of gradient based learning based optimizers like vanilla gradient descent or momentum or RMS prop or ADAM, depending on model to model. Different techniques. Maybe a simple maximum likelihood estimation may be a way to optimize it. So maximum likelihood estimation may be a technique to go for it. So we come up with different models. We kind of minimize the error function, or we maximize the log of likelihood function in a way. While optimizing some kind of a function, we want to find out the right model parameter for which the joint probability or the probability of y given x and model parameter is highest, and then this in some way is connected to some linear combinations of input or a chain of linear combinations of input. That is a separate discussion, and it may require a lot of videos to understand model training properly, but it is kind of vector calculus linear algebra aspect to it. Although in current days we can use a simple Python library, in a few clicks we will be able to train a model. Again, I'll say that you don't need to be a mechanical engineer to drive a car. Driving a car is a very important and a completely different skill set, and mechanical engineering is a very important and different skill set. Similarly, there is an importance to understand the mathematical aspects in machine learning and data science, but in today's world, you don't need to understand it deeply to build a model. But in this course curriculum, we are going to understand them thoroughly. So, after model training, an important parameter or important step is model tuning. So there are different parameters which are also there but which are not trained by an optimization algorithm, like learning rate, right? Or like there's something called regularization. So whether we are using L1 or L2 norm regularization. There are different kind of maybe train test split, how much data we are going to use to train the model, how much data we are going to test the model. So in a way, then there are some parameters like radio that we use to fine tune the model, to configure the model so that we can come up with the best trained model of prediction, like the prediction that we want to do, model tuning. So once our model tuning is taken care properly, then next step is going to be model evaluation. Now, there are different matrices depending on the problem, depending on the machine learning algorithm, depending on the model that we use to evaluate the model. For example, confusion metric is there. Or then there may be different charts that we create, the reduction of loss function over the period of time, accuracy, precision recall, different matrices that we try to figure out. And looking into these matrices, we kind of understand the current performance of the model, and if required, we again train it or fine tune it or do whatever is necessary. Again, we will understand that this do not go in a linear fashion. If you are from software engineering background, we do not go on this pipeline like a waterfall model. It is iterative. So you may jump from step 1 to step 3 to step 2 to, I mean, you don't jump, but there may be an iteration going on. So once we do model evaluation, then we deploy it. So deployment to a production server. production environment, production server, where you may have to come up with all the criteria of load balancing or the overall demand that the model is going to serve. So may come up with some kind of a cloud service, then deploy it on an EC2 instance or a load balancer. And the last is monitoring and updates. So we monitor the model, monitor its performance, and do some updates if necessary. So these are the 11 steps. Now, one important thing, it's not like step number 1, then step number 2, then step number 3, then step number 4. There are backward feedback too. So this is also possible. So you may reach to step number 3 and may have to come back to step number 2, or may have to come back to step number 1, which is in a way disaster because you are to a training and then you are understanding, redefining the problem statement, but it is in a way iterative in nature. Iterative in nature. We follow the procedure, we follow the standardization, but we kind of make the entire process agile. So this is an entire pipeline that we use to go for any machine learning process. Now this is a general understanding, and some different data science projects may involve some other activities too. But on a larger perspective, this is what we follow. In upcoming few videos, we are going to look into each of these steps in much more detail. So I hope you like this video. I hope you will like and subscribe, and see you in the next video. Thank you very much.